An equation of the form dy dx plus p of xy equals q of xy raised to the power of n is called a Bernoulli differential equation. And we observe in this differential equation that if n here is not equal to 0 or is not equal to 1, or if it is equal to 0 or 1, we can actually identify this equation as a linear equation. But if n is not equal to 0, then we have to be able to express this into a linear equation by introducing a new variable. So let's say we're going to let u equals y raised to the power of 1 minus n, and finding its derivative with respect to x, du dx is equal to 1 minus n, y raised to the power of negative n, dy dx. So we're going to use that later. We're going to go back to the Bernoulli differential equation. Using this equation right here, we are going to multiply both sides of the equation by y raised to the power of negative n. Again, this one, we're going to multiply both sides of the equation by y raised to the power of negative n, such that multiplying by y to the power of negative n, we have y to the negative n dy dx plus p of x. If we multiply y times y to the negative n, that would be times y raised to the power of 1 minus n equals, we multiply this with y to the power of negative n, so that would be y raised to the power of 0, which is equal to 1. So that's equal to q of x. And from the differential earlier, we can substitute this such that y to the negative n dy dx is actually du dx over 1 minus n. So substituting that, again, from this one, we can actually write that as du dx over 1 minus n equals y to the negative n dy dx. So we are going to substitute this here because that's the same. So replacing this one, we have du dx over 1 minus n plus p of x y raised to the power of 1 minus n equals q of x. And then we multiply both sides of the equation by 1 minus n. Then we have du dx plus 1 minus n p of x. What is y raised to the power of 1 minus n equal to? That is actually u. So u equals 1 minus n q of x. And this is now a linear equation. And in this linear equation, we can see that our integrating factor v is actually equal to e to the integral of 1 minus n p of x dx. That's our integrating factor. And our solution to the dE, if you recall, is your integrating factor v times your dependent variable u equals the integral of v times the term here, which is 1 minus n q of x dx plus c. But your u is y raised to the power of 1 minus n. So that's vy raised to the power of 1 minus n equals 1 minus n integral of v q of x dx plus c. So the concept is the same. Whatever variable is dependent or independent here, the concept in deriving the integrating factor and the solution to the Bernoulli differential equation would be the same.